Welcome to an introduction to PowerShell Module 4 dot sourcing. My name is Brian Cafferkey, and a little about myself. On the right hand side you can see my Twitter account at Brian Cafferkey. I'm also on LinkedIn. Name's kind of rare, so you shouldn't have any trouble finding me. Cafferkey's not that common on LinkedIn, but I'm out there. Also, my email is brian256@msn.com. Feel free to email me with questions, whatever. Also, please subscribe to me on YouTube. I'm doing a long series of videos trying to cover PowerShell particularly as much as possible, but I'm going to be getting into other topics as well. I'm a data solutions consultant and trainer with BBC Global Solutions LLC. I'm a Microsoft MVP. I have decades of IT experience, also the author of Pro PowerShell for Database Developers by Apress and available on Amazon.com. Also a SQL Pass chapter lead. I lead the Rhode Island Microsoft Business Intelligence User Group. I also lead the Southern New England R User Group. These are both on Meetup, so if you're in the Mass area, you may want to join the groups. And even if you're not, we do webinars also occasionally, and so you may want to join one of the webinars we do. So what we're going to be talking about in this particular module is reusability and the use of dot sourcing to support it. So we'll start out by discussing reusability in general. Then we'll look at calling PowerShell scripts both directly and by using dot sourcing. We'll look at passing parameters and returning values, common parameter support, and we'll take a look at what that means, but it gives us some really interesting and advanced functionality, defining functions within dot sourcing, and we'll look at the what if and confirm parameters, which give us some sort of a safety net. So reusability. The idea behind reusability is to write our code and test it once and then just use it. If we have some logging functionality that logs to a table and does certain work and everything, we don't want to have to keep writing new log functionality over and over again. We would want to write that log code once, and maybe we pass in things like, what table do I want you to log to? Maybe I place a flag in that says what types of messages, warning, errors, critical errors, etc. that will filter. But the the log functionality is handled in one place. That's it. And by doing that, every time I want to do logging in the future, I just pick up that code and call it, and I can have it do logging, and I've got immediate support for logging without having to write the code again. I also don't have to keep taking code maybe that I had and making changes to it, changing hard-coded paths and file names and table names. Now I don't have to do that because that can introduce more bugs. So the idea instead is to modify the behavior using parameters. And if you've seen functions ever coded, you know that's what the idea is. You pass parameters to the function, and based on those parameters, the behavior changes. It does something different. We see this with PowerShell functions, which we call commandlets. We do something like get child item as an example, and we can pass it a path to say what folder did you want to list and get the items in. You can pass it that way. You can say remove item, and then you give it the name of the item. So it's not hard-coded. It takes parameters to control how it behaves, and that allows us to reuse over and over these commandlets to do things for us. In the same way, we can create our own code blocks and reuse them and control them by the use of parameters. So the idea is to sort of bundle up, wrap up functionality. And generally want to call code to do sort of one task so that we can get a handle around it, saying we want you to log items or do something. We don't want to make it so sort of convoluted with different myriad of things going on that it's not really reusable. The idea there is called encapsulation. And I should point out that when we do dot sourcing, and most time when we use reusability, functions and things can return values to us. Now a very common practice, I put this in red at the bottom, a common thing in I think PowerShell in general is to pull up a script. We're always under the gun, especially administrators. I just need to get this Active Directory change done. I just need to get this folder copied, whatever. And so the tendency is to pull up a script we've used before, make changes to hard-coded values, run the script. Next time it happens, do it again. And the problem is you run the risk of introducing a bug anytime you do that. You forget to maybe close a quote on a string parameter. You put an extra comma somewhere you don't need it. Any number of ways you can corrupt it, potentially introducing a problem, like deleting a file you didn't mean to or causing some problem you didn't want to. And so in general, that's a bad practice. And in programming, in my experience, Very rarely do we have the true one-offs. I find that, my boss will come in and say, we need this, we just need it this once, I just want you to get this. And your boss, generally management always wants things so fast. They kind of don't understand the impact of doing things quick and dirty, as they say, and that in the long run, that's sinking everybody. So you have to sort of force yourself, and they don't need to know that you're doing this, but make it reusable, because that one-off that your boss asked you for is likely to come back again and again, and you know that and I know that. So by writing reusable code that you can just pass parameters in, you're great. Next time your boss comes and says, I know I said I would never want it again, but could you do this? You can kind of frown and make a big deal and say, sure, I'll do it. But you made it reusable, and in 2 seconds you're done, and he's happy or she's happy, and you're good. So dot sourcing. Dot sourcing is one way in PowerShell to get this reusability. And for calling scripts, it's very powerful compared to, say, the old DOS days. So we'll take a look at this a little more closely. So again, we're calling one script from another. The called script may return values to the calling script. And objects created by the called script are visible to the calling script. And when we're done, the called script returns to the calling script basically in the line after where it was called. So let's look at the diagram in this picture. We can see my parent script on the left, .ps1, some code going on, whatever it is, and those are comments. But then we see my script 1.ps1 being called, passing a parameter, some val, and it's got the full path, but it's got a period space and the path to the script, and that's going to dot source the script, which means it will call the script, start at the beginning of my script 1, run through till it hits return or end of the script. And when it's done, it's going to return and execute the line after the call, which is in my parent script 1, so it can continue on. And then it will go to hit the next line, which says call my script 2.ps1, and it does the same thing. And again, values can be passed back. Things to keep in mind when this is happening is objects, and this is in the little box to the right, objects created in memory are retained. We have shared memory, so objects created in memory are retained and visible to the parent script. We can pass parameters. We can return values. So we have a lot of functionality. We have almost the functionality of functions, but the shared memory can get us a little bit into trouble, because what if we wipe out memory that's being used by the parent script? We could have a problem. We might replace a variable or do something, so we have to be a little cautious of that. All right, so let's take a look at this more closely. Run PowerShell. I'll start out with call script 1, and what I'm going to do first is clears the host, it's the console. I'll run that just to clear the console below. And we're going to set location to a special reserved dynamically created variable in PowerShell called $psscriptroot. Now if I try to look at it without running a script, it's got nothing in it. We can see, right? Nothing here. But when it's running, I'm going to display it here, so you'll see it gets a value of the full path to wherever the script that you're running is in. So when the script runs, it actually creates a dynamic variable, PowerShell does, which you can look at, and that has the pointer to where that script is, which is great because we're going to use that to our advantage so we can point all the called scripts to it. And I'm doing that to make it life easier for me so that I don't have to hard code the path to these other scripts I'm calling, and I don't have to manually navigate to that folder. Instead, set location is going to automatically change my default folder to wherever this script is, the script I'm running, and I'm going to make sure that my subscripts or my child scripts are running in that folder. So let's run this. And I want to point out something too. So we're doing this. Now I have these remove variables, and I'm doing that for a reason. The idea of removing these variables is so that I can show that what's happening in here, these variables are not going to be retained. So let's look at return values for a minute. And what I see is happening in the script I'm calling is I'm creating var1, $var1, Brian is cool is being assigned to it, $var2, something else is being assigned, and then I have return going back. That's it. Again, go back here. We can see that return value, Brian is cool, happened. It returned that, and it printed it since I didn't do anything else with it. And then I see back in parent script, just to prove we're back here, right? That is the line after the script that got called. And then I'm displaying these two variables, but they're not visible. What happened? Those were created again in my child script, but they're not here anymore. Now I want to point out, this is not dot sourcing. This is, I'm just calling the script and running it. If I were dot sourcing, I'd say period space and that's how I would do it. We're going to see that in a minute. That will retain the variables we created in the child script. But because I didn't do that, these variables are gone. It ran the code in here, but anything created by that script would be deleted from memory when it returns to the parent script, which can be useful if we have some very large objects we're creating, a lot of memory consumption going on in the child script. This might be the way you want to call it. Do something, but get rid of it afterwards. For instance, maybe we load a large file into memory using get content, and not something we want to keep because we could start dragging the machine, hurt performance, and just add more consumption of resources. This is a good way to do that. However, it's not good if we're creating, we'll see later, functions we want to keep in memory or any other kind of variables or things we want in memory. Then we lose that feature. All right, so we can see now this, just so you know what this is, remove variables is making sure if these variables exist, it gets rid of them so that it's kind of a clean slate, because I've been testing and playing around, and you can rerun the script for that reason. And this error action is a parameter that says if I don't do that, then I'll get errors when it tries to remove the variable if they don't exist. But error action silently continues, says don't complain even if the variables don't exist. Okay, so that's the first call script. Now let's look at another way of calling the script. In this one, this example, we don't really need to do the set location again, and I want to step through this, so I'm not going to just run the script in this case. I'm going to run clear host. Let me run these lines of code and we'll walk through it. So I clear host, I assign a variable var1, and I give it a value of this thing. Then I'm dot sourcing. This time it's different. I'm dot sourcing and I'm running return values. So I go back here and I can see I have a $var1. So what's going to happen with the one I already had in the parent? And we have $var2 and we're returning a value. And the return value, as before, it came back and returned the value, return value, Brian is cool. And when I went to print these two variables, it printed them, Brian is cool, and something else. Those are two variable values that were in these two things. What happened here? I created my own variable before I went into this script. And let's see, if I, just to prove it really has a different thing, it reassigned it. So my parent variable was overwritten by the called script. So something to be aware of, because you can get burned by that, obviously. If you're not careful and you end up one variable, one script you call uses the same variable names, you better be prepared for that because it could introduce bugs that could be difficult to clear up. But the important thing also is to realize that now that I'm dot sourcing, when I create variables in the child script, they are visible and permanent. They're there for the parent script as well. Now I want to do something else. I'm going to do dot sourcing just as we did before, but the return value I'm going to return to a variable. And let's try just doing that. And notice it didn't show anything because it's just the command prompt came back. But now if I go and look at retval, it shows that it's got that message, right? So you can see it returned the value to my variable, which is kind of nice because it's like using it as a function. We can store the results from a script in a variable on the fly. Now I want to show a little more complex here. We're going to do return vals2 this time. And this is a file list, and we're using getChildItem, which is a full folder listing. And we're going to basically store it in this variable and return it. And let's see what that looks like. So again, let me clear host for a minute. And I'm going to call this. And as before, it doesn't show anything, but now let's take a look at what's in retval2. And you can see it returned the entire collection of the folder. And that now is an object that we can use, and we can even get properties off it, etc. So again, it's a nice little feature that you can do that. We can return complex objects, not just simple ones. All right, let's take a look at another way of doing dot sourcing. This time I want to demonstrate the use of passing parameters to our script. So I'm going to, again, I don't need the set location in this case. I'm going to say clear host. And I'm in .NET source, and I'm calling scr underscore take some parameters ps1, and I'm passing a name, a number, and a path. And let's look at the script. I have it up over here. So I have script, and nice to have comments here, etc., explaining what it's doing. And to take the attributes, I use this param block, which allows me to define my attributes, which are my parameters, I should say. So here's parameter 1. I'm going to pass name, I'm going to pass age, and I want to path to a file. It's just kind of random there. The data type of name is a string. Data type of age is an integer, and then a string is for the path. And I can add some other attributes. For instance, I can say here, the parameter parentheses mandatory equal true. That's called an attribute. By using that parameter attribute, I'm requiring this parameter to be passed. It must be passed or I'll get an error. The other thing I'm doing here is I'm saying validate set. When I pass a value, it better be in the values of Tom, Dick, or Jane. It can't have any other values. For age, I'm validating the range. It has to be between 21 and 65. And I'm going to do a validation script. When you pass in a path, I'm going to verify the path exists by running dynamically a little mini PowerShell script, and that's what's between the braces. And I'm running the command like test path, and the $_ is that particular parameter being passed in. It doesn't have a name yet because we're giving it a name here. So it's using this sort of placeholder $_, which we'll learn later is actually the name of the pipeline current row. So that's what it's essentially doing there. All right, and then what the output is, it's going to write output. Wow, $name, you're 8 years old, write output again. Now I'll throw a little tidbit in here. The reason I'm using write output as opposed to write host is because, not that it matters here, but write output will be passed into the pipeline if we ever choose to pass this stuff into the pipeline, whereas write host bypasses all that and goes directly to the console, in this case the host, whatever it's running. So sometimes it's better to use write output, and write host is what everybody uses, so let's be different. Also, I'm using this write verbose. We're going to talk about that in a minute as well. Now, I want to point out that this write verbose is what's called an advanced function parameter, or common parameter. And what it does is it will only do the write verbose if I pass the verbose parameter. Now, I don't have in this particular example, I'm going to show you another way to activate that, but it's really because of these advanced attributes here with the parameter block, which triggers the support for write verbose. So let's go back here, and let's just step through this. So I'm going to run now, take parameters, I'm passing Tom 33C, and it said, wow, Tom, you're 33 years old, and then it says that the C path was verified. Now, just to show what happens if I try to do something that doesn't fit the list of what's in Tom, that verification part, gives me an error, and it says cannot validate. The argument Tom does not belong to the set Tom, Dick, Jane, which it's correct, it does not. So that's the kind of neat thing that the validation will do. It'll make sure that our validation rules are met, so kind of a good way to make sure we get safe parameters. Now let's look at what happens with the verbose. Oh, let me see. Oh, again, so let me fix this as well. I'll make it Jane this time. Did not like that name. And here, the number's wrong because 99 doesn't fit a valid range. So I'll change that to 34. And this path should be good. So we should be good. And notice that now we have this verbose messages coming out. So verbose messages are part of common parameters. We're going to look at those more closely in a bit. But what they do is they allow us optional informational messages. This message will only print when I pass the -verbose parameter. Really, really useful. It's one of my favorite things because when you're developing scripts or when you have questions about if it's running, maybe you just want some feedback while it's running, you can have write verbose messages. And when you put it to production and when other people are using it, as long as they don't pass the -verbose, they never see those messages. So they're awesome useful informational messages that are optional when you want them. Really nice feature, and all we got to do to use it is just dash verbose. Again, I'll show you later, there's another attribute typically used to activate this functionality, which is commandlet binding. But if I did not have these parameters with these attributes defined, then the dash verbose wouldn't work, the write verbose. But because I'm using some of these advanced attributes, that kicks it in. All right. I'll show you more. There's actually a better way to define this. I'll show you later using the commandlet binding attribute, but we can see that this works as well. It's kind of getting around that. Okay. Now let's go back. Call script 3. So what we want to do in this particular one is we're going to call the script, and this is how I would personally recommend using dot sourcing as opposed to the other ways. The other ways work and they're pretty powerful, but it's a little cleaner if you instead create functions. And I'm going to talk about functions in a different module, so it's not really covered here. But functions are self-contained and meant to take parameters, and they're really, for all practical purposes, commandlets that you can write yourself. So they're really designed for reusability, and they give us more flexibility and are safer than just calling scripts the way we've done so far. So I'm going to, in this case, clear host and call scr define functions. And let me open those up. And this is scr define functions, and here's the functions being defined. So I've got two functions. This function is one function, and it's called out UDF user message, and then I've got another function being called out UDF careful message. These naming follow PowerShell conventions, verb-noun, and UDF is so I know the prefix I use on the noun, so I know it's my own function and not one of PowerShell's. Because if I was in cases where I have a lot of functions maybe being imported, I might get confused as to whose function this is. And I mentioned earlier that when you want advanced function support, you can use the commandlet binding. We noticed earlier that when we used attributes with parameter, the param block, it also worked. However, using the param block without any of those other parameters like validation does not kick in the support for doing the common parameters. And the common parameters, one of which we saw was dash verbose, another one is dash debug. So we'll take a look at that in a minute, but the idea of running this script is that when we call the script, it's not going to run this code. We have to tell it explicitly we want to use it. Instead, it's going to create these functions and store them in memory so we can access them. So let's go back to our calling script. And I'll just run this clear host and then call the defined functions. And notice it didn't do anything really. Just said OK. Now I'm going to call out UDF user message, passing the name Robin and an age of 44. And we didn't bother with the other parameters, so we've, hi Robin, you're 44 years old. We didn't have a path parameter in this particular one. What does this debug do? Let's try that. We're going to do the same thing, but now we're going to say debug. And notice we don't have the validation stuff, so it's not stopping my names. I can pass in what I want. Run this. The debug says confirm what's happening. I can stop the command. So this is great again for debugging purposes. I can stop the command and I can decide what do I want to do here. And one of the things I can do is suspend. I can say yes, continue the operation. Now if I am going to do potential damage to something, I'm afraid there's a problem, or I have some bug that I want to check out, I can suspend and then look around and do stuff. So let's try suspend for a minute. And now what I am is I'm actually in sort of the function level, and I can do things like take directories. I can look for variables. I can say there's a provider called variable : that treats the variables like a drive. And I can then see all the different variables that are available. So the idea here is I can suspend operations for debugging purposes, poke around, see what I want to do. When I'm done, just type in exit, and I come back again to the prompt, and I can say, yes, I want to suspend it, or I want to continue. And I'll say, yeah, you can continue. And I think that was about it. Let's see. Yeah, let me try this again because I think it should have continued, and I'll say yes to all. And now we got not only the message, we got the debug message as well. So the debug message came out because we said, yeah, you can continue. All right. And then finally, we're going to use the verbose parameter. So verbose, let's run this and we'll get an idea what happens. With verbose, we get the verbose message here, but it doesn't stop execution. And there's a little more to this. I don't want to get overly bogged down, but there's behind the scenes, there's PowerShell configuration variables that control what verbose and what debug do. And any of these could actually prompt you and say, do you want to continue? Or the default behavior is called silently continue, which is why unless you put in the commandlet binding support, it ignores them. And unless you pass the parameter, for that matter, it'll ignore them. But when you do the dash verbose and dash debug, you're really passing what are known as switch parameters. And they're just Booleans, but by just passing them, they become true, and they affect the way things execute. But the bottom line is, by using dash verbose now, we'll see the verbose messages. And we can see that would be this message. So again, I really like the verbose because it's a great way to print out variables and tell you, if you get a long script, I'm opening the file, I'm writing to the file, I've written to the file, I've got so many lines in the file, and whatever it is I'm trying to do, and it helps me debug and just trace through a script that's running. And then I want to put it in production. Instead of having to worry about commenting out all those extra print lines or whatever, you just don't pass the verbose parameter and nobody knows they're there. All right. Now there's two other common parameters which are very cool, and one of the things that I think I love about PowerShell is that it's really clear that Microsoft thought carefully about what do people really do, especially in the Windows admin world, but just in general, like what do people do when they use programming languages? One of the things that we do is we worry. We worry that our code might break something. We worry that we might bring down a database. We like to keep our jobs, and bringing down a production database during the day might not be well received. So what we can do is protect ourselves a little bit by using these special common parameters, what if, and confirm. So first I'll show you how they work, and then we'll take a look at how we can code for them ourselves. So stop process is a special commandlet. It's built-in commandlet to PowerShell that will take a process that's running a program in memory, and we can say stop it. Now again, that's a dangerous commandlet if you think about it, because what if that process is your SQL Server database? What if that process is a Windows kernel? So you might have a problem. So what Microsoft does is they give you this parameter, what if. This allows us to sort of test out what would happen if I ran this particular commandlet. And instead of actually doing it, it says, what if performing the operation stop process on target notepad 15832. And then maybe you look and you say, oh wow, there's two notepads running and one of them has that program I still haven't saved. Whoa, good thing I didn't do that. So the idea here is to give us this sort of cross-check. And now if I were to run it without that parameter, it'll just run through and terminate that process. So I've got a function, out UDF careful message, which we just created, and I'm going to pass that what if parameter to that. And what I get is performing operation out UDF message, so it shows you the function on target, and then this is a message that I'll show you what I defined for it, deleting test file.txt. So it's warning me that this is what it would do. Imagine if it warned me shutting down production server A. Good to know. So let's go take a look at how the function is defined. So here's the function. I wanted to have the support for the confirm and what if parameter. Now having the advanced function support commandlet binding by itself, as we did here, is not enough. And by the way, anytime you put this in your code, that will give you support for the common parameters. And that's the best way to do it. I would highly recommend always doing that when you want common parameter support. But we also have to include this switch setting, support should process equal true, and that puts in support for the what if and confirm parameter. And then what we need to do is wrap our code that could be dangerous, the part that can change our system for the worse. We wrap it around this if statement, and we just say $PS commandlet should process. What we put in here is the message deleting the which will be displayed when we do the what if. We can see it here. And it does not run this code if we did the what if. So it just displays the message and tells us what it would do. So that's pretty powerful. Again, it's a great idea if you have high-risk situations and a nice way to test things. And again, maybe you're going to be doing a lot of things and you don't want to be deleting and recreating files. So it's also a way to sort of do some testing without actually changing physical things that could do damage. I want to take a look at another thing we can do, as I mentioned, the confirm parameter. So this time I'm going to say stop process, notepad, but I'm going to pass the confirm. And this we saw again similar to the debug. Do we want to stop? Do we want to do this? We can suspend and look around some more, try to debug a problem. I'm going to say no, you know what, don't do that. And it just exits. It doesn't actually do the problem. That's with the built-in command. It's not going to run that process or stop notepad. I can add support for my own functions, which I did. And here we have the same thing. We say confirm. And so we can also do that with our own function. Confirm before we run it. Now, if we take a look at define functions, one of the things we have is this confirm impact equal high. And the reason we have that is we want to force, we're telling PowerShell that the risk of this function is high. It's a risky function. It may be doing something that could cause us to look for a new job, perhaps. So we want to make sure we're careful. We're telling PowerShell this is something we want to be careful about. So what happens now is if I try to run that function without even doing the confirm parameter, it still prompts me because we're worried about it. And we might do that again if we're a DBA or a Windows administrator and we're allowing these functions to be used by other people. It might be a way to sort of warn people that this could be dangerous. Please be careful when you run it. It's also a good way to sort of prompt ourselves before we run something. We know, oh yeah, this is shutting down a server. I better put that high priority up on it, that riskiness up by using confirm impact. So the confirm just bypasses everything. If we do the confirm parameter or we do this high impact, and we can just say no, and it just stops running that. Now notice it's not actually running our other if test. It's not giving us messages. It's just a matter of prompting us and saying, do we want to run it or not? But I love these features because, again, especially when you consider Windows was originally really designed for Windows and server administration and those types of things. And you can get into trouble if you don't think about what you're doing before you do it, especially if you're in a production environment. So I'll do a little review now of all the stuff we've covered, which is quite a bit. We used set location to just put our default location, our default folder, to point to a certain place. And once we've did that, if we have scripts that's where we want to run them, then we can use that folder by just doing /. So that tells us that the script is in the current folder. If we didn't do that, but we wanted to pull up a script or run a script in a different folder, we'd have to give it the full path to that folder, as we did in the last line on this slide. Now when we want to call a script using .sourcing, the things we need to keep in mind are all the variables, functions, and objects created are retained in memory. We can pass parameters, as we saw. Values can be returned, and we demonstrated that. And we saw how to get support for common parameters. The best way is to put that command-let binding attribute in. But we saw that when we used the param block and used some of the advanced attributes like validation attributes, that also sort of triggered that support. But again, I would say always put the command-let binding attribute in to get it, because it's more consistent and it always gets it. And we noted that objects created, variables created in the child scripts are visible to the parent, and we saw how we can even trample our own variables if we're not careful. And this was an example of using .NET sourcing passing parameters. So we put a period space, which is the .NET sourcing piece, then period / name of our script, which is going to be found in the current folder due to the period / and the parameters we want to run. And then we can have things in the second line example here. We're passing the -- verbose parameter, so we'll see the verbose messages. And when we did define script parameters, we used a param block. And I'll make a little sub-reference. You'll see a lot of interesting overlap in this particular part with Azure and what they call runbooks. If you do runbooks, this param block is exactly the same. It uses param block. So a lot of overlap in what you learn in just basic PowerShell and how it can be used in other places. Back to our program. Okay, so the param block here, you define it with the param name and then open parens and then your parameters. And you don't have to have all these different special attributes like parameter with its mandatory, the validation step, but we saw that it's nice if we need to validate parameters coming in and we want to make sure they're safe. And we noticed even things like the validation script will run a block of code on its validation, and in this case validate the path being passed in. And here you can also see write verbose is only going to be triggered if the dash verbose parameter is passed in. And this just to remind us, how do we return values from a script? We don't have to use the return function, but if we do, we can say return and then whatever it is we want to return to the parent. And we even saw that we can assign the return value to a variable from the parent. Okay, and we looked at the what if and confirm parameters, which are also common parameters, but they require a little extra work on our part when we want to add support for them. But we saw the stop process in this case is a built-in commandlet, and we can use the what if, and any kind of risky commandlet in PowerShell like dropping files, deleting files, rebooting your machine will support the what if, so it tells you what it's going to do before it does it. And the second example here we say out-udf careful message, and the dash what if shows that we can implement our own what if support in our functions, but we had to do the separate coding test. And we see the confirm parameter stop process again can be used in a built-in commandlet, and we can add it to our own as we do in the last line. And looking at the sort of function part of this that we called, but we created that with the .NET sourcing, the function has the commandlet binding, which automatically gives us common parameter support. But in this case, it includes the support should process equal true. It's setting that flag. And by doing that, it allows us to have support for both the confirm and the what if parameters. And then we have the code below, if PS commandlet should process. That's used by what if as a substitution. If they pass what if the person calls this function with what if, it will not do the block of code remove item. Instead, it will just call this, really that should process as sort of a function, and it will display the test file .text message, whatever we put in quotes there, along with the function. So we'll basically tell it what it's going to do. I would have deleted your file or whatever it is, your message there. So it's telling you what it's going to do, and it's good for testing, it's good for safety, to make sure you want to do what you're going to do. Now for the confirm, we wanted to make sure that whether or not you pass the confirm parameter, we want this to prompt you. We want this function to always prompt you and confirm you really want to do this. And we can do that by saying confirm impact equal high as one of the commandlet binding parameters. Now this slide shows all the common parameters that are available. There's a lot of them. All different kinds of parameters in here, and we saw some of them. The ones I think are the most useful, the ones I tend to use, we've discussed now. The only other one that might be interesting is the use transaction parameter at the bottom. That only works when you're dealing with the registry, but it can be useful in that case because if you modify the registry, the idea with use transaction, and it has a corresponding, you can do rollbacks and everything. It's very similar to a database. The idea is that you could mess up the registry so you can use this sort of transaction context as a way to carefully modify the registry, and if something isn't right, you can back it off. The pros and cons of dot sourcing. It may seem like it's all pros, and generally it would be, except I think there's a better way to get the benefits of reusability, extensibility, maintainability, but I want to talk about still the pros of dot sourcing. If you're not going to do anything else, if you're just doing scripting and you're not really getting the benefits of reusability, then definitely use dot sourcing because it's better than that hard-coding scripting approach and just modifying scripts all the time. So the pros are it's easy to use, and I think that's why people adopt it. It's great, and that's what I started with. I was dot sourcing my way everywhere until I learned, became a little wiser, I guess. And I don't want to put it down. It's great. But when you're really supporting more production level code, something you're going to share and deploy, then you may want to think of a different approach, which I'll cover in another segment or another discussion called modules. It provides flexible code reuse, as we saw. It's a great way to test functions, so it definitely should be in your toolkit. And it supports reusability, extensibility, and maintainability. Now, we talked about reusability. Extensibility meaning the idea of extensibility is we can extend functionality. So maybe we have a script that will send an email, but maybe we really also want to do some login when we send an email. So we could have a send email and log, we'll say script, and it calls both the email and the logging within it, and we can have parameters to that. And so we've essentially created a new command that we can use and gain that benefits reusability, but also that extensibility. Now PowerShell, it's as if it had a brand new command available. And we saw functions, and the functions are a great way to extend PowerShell. And that is, the primary method of extending PowerShell with functions. And we can do function creation within .sourcing as well. Maintainability, because if we keep things in one place, we can make it easier to maintain our code. We reduce the risk of errors since the function or script has been thoroughly tested. Then we can avoid risks of introducing bugs every time we modify it. But also, we have it in one place. So if we had, say, one send email and log example script in one place, and that's always where we used it from and called it, then it doesn't matter if we used it in 1,000 places. If we needed to change something, maybe there was a compatibility issue in PowerShell or some reason, or we want to add some new message to it, we only have to go to that one script and fix it there. We don't have to go to 1,000 scripts because we created all these different versions. And that's the problem with proliferating similar code. The cons? What I don't like about .sourcing is it's sensitive to script file locations. As we saw, you need to be aware of where the script is. Now, I kind of got around that a little bit by using the PS script route and then just basically using the period backslash to say everything's here. So it kind of made it a little bit easier. It makes it easier to sort of share things, but it's still a little risky, and you can hard code file paths and do things. So I think it can be a little messy that way. And not to mention that the scripts themselves, there's no inherent way to know where you should find the parent scripts. So there's some issues there. And if you make a change, if you hard coded a path or you whatever, then you might actually be running a script you didn't realize because you didn't change that path. So that's the biggest issue I see with it. Also, that it shares memory with the parent script. I cringe a little bit at that because I like to keep things as modular and isolated as possible. So I prefer to call a function, pass parameters to the function, let the function do all of its work in a self-contained way, scoped only to within that function, and then return back what I need from the function if I need a return value, and avoid any kind of sort of damaging of my parent environment from the child, because that's just a way to introduce bugs that can really get to be difficult to find. So we've covered a lot in this module, and I want to kind of review things here. We looked at reusability with .sourcing, and we looked at the benefits of reusability, which I hope I've sold you on. If you're a Windows administrator or somebody who's not a developer, it may seem less critical to you, this reusability and extensibility idea and things, but I really want to emphasize, do not ignore it because it is extremely valuable. And the reason developers know that is because they've been burned enough by not doing it, and then they learn the hard way. But if you're not used to writing a lot of code, then you may not see the benefits immediately. So that's my plug for it. The period backslash is needed if we want to call a script in the current folder. We can pass parameters and return values, as we saw. We can implement, using the command-let binding attribute, the common parameter support. And we looked at defining functions by .sourcing as opposed to just calling the script and letting it execute. And that, to me, is preferred. And I will cover functions and modules in another presentation, so I don't want to get too much into those. And finally, we looked at the what if and confirm common parameters, which take a little more work to implement, but are really powerful, especially if you are doing, administration type work in which you could be running some very potentially damaging code, and you don't want to, you want to be careful how you use that code and how you run it. And so those are really useful for that. So So I hope this is useful to people. Feel free to leave comments. Let me know. Again, subscribe, all those good things. Let me know what's useful and what isn't, but I want to kind of step through each major segment within PowerShell functionality. It's a very rich environment and language, so I'll try to take it in segments. But I hope this has been useful for you, and please try out some of the things, and I will make this available also on my GitHub account, and you can get it there, and hopefully I'll plug that later, but it will be available on GitHub, and thank you. So I just wanted to add this last bit. I forgot to include where you can get the source code to the Module 4 .NET sourcing topic, and it's at the link below. So it's available on my account at GitHub, and if you've gotten the last module code, it's in the same area. So it's under my account under PowerShell YouTube Module 4 .sourcing. You should be able to get at that. Let me know how it goes, but those examples should work on your machine, and you should be able to put those wherever you want. It's not, as you saw, contingent upon location. Thank you.
Hi, I'm Brian Kafke. I'm the voice behind the videos. I hope you've enjoyed them. Hope you consider subscribing. My plans are to do more educational videos and things related to the IT world, in particular on the data platform. So I want to keep going with the PowerShell training, but I also do a lot with R, do some things lately with Python, and a lot of things with the Microsoft SQL Server stack. Also quite well versed in Oracle and PostgreSQL. So a lot of different areas I'll probably look at over time. And I hope you're enjoying this. And if you have any comments or things you'd like to see covered, please let me know. Thank you.